Hi friends, today we are going to discuss the problems related to the auto cycle. Now we enter to the problem. In an auto cycle, air at 70 degrees Celsius and 1 bar is compressed adiabatically until the pressure is 15 bar. Heat is added at constant volume until the pressure rises to 40 bar. The swept volume is 0.711 meter cube. Then calculate the air standard efficiency, compression ratio and mean effective pressure. This is the problem which we are going to solve now. Say first, what are the problem given in gas power cycles? First, you read the problem twice or thrice. So try to understand the problem. First, in an auto cycle, if they give which type of gas power cycle they are given, you first draw the PV diagram for that. In this problem, they give auto cycle. So in an auto cycle, so you must draw the PV diagram for the auto cycle. In an auto cycle, air at 70 degrees Celsius and 1 bar is compressed adiabatically until the pressure is 15 bar. That means the initial pressure and temperature of the cycle is, the initial pressure and temperature is here, P1, V1, T1. In this place, the piston is placed in point 1. So air at 70 degrees Celsius and 1 bar is compressed adiabatically until the pressure is 15 bar. That means then the air is compressed until the pressure rises to 15 bar. So this is process 1 to 2. Here the pressure is 1 bar and the temperature is 70 degrees Celsius. That means P1 and T1 they given. Then the pressure is raised compressed adiabatically until the pressure is 15 bar. That means P2 value, the 1 bar pressure is compressed up to 15 bar, P2. Then heat is added at constant volume until the pressure rises to 14 bar. So that means the pressure is already in 15 bar, then we added the heat. Automatically, if the heat is added to the air, means its pressure is automatically increased. So here the heat is added and here the heat is rejected. Qs and Qr. What they given? Heat is added at constant volume until the pressure rises to 40 bar. That means the P3 value is 40 bar. Pressure rises 15 bar to 40 bar because of heat is added at constant volume. P3 is equal to 40 bar. Then the swept volume is 0.7113 meter cube. The swept volume is nothing but Vs. Vs stands for V2 minus V1. That is the swept volume value. So then calculate the air standard efficiency of the auto cycle, compression ratio and mean effective pressure. First you read the problem and understand the problem, then you write the given data perfectly. Without you write the given data correctly, you can't able to solve this problem easily. First they give pressure. The initial pressure and temperature of the piston is, cylinder is 1 bar and 70 degrees Celsius. Then the pressure is adiabatically compressed. See, 1 bar is compressed adiabatically until the pressure rises to 15 bar. Then heat is added at constant volume until the pressure rises to 40 bar. So you write the 1 bar or 1 into 10 power 5 Newton per meter square. You write the temperature in terms of Kelvin. Then swept volume is 0.711 meter cube. Then the required data are air standard efficiency. The air standard efficiency of auto cycle, the formula for air standard efficiency is 1 minus 1 divided by R power gamma minus 1. So this is first required data. Then the second one is compression ratio. Compression ratio R is equal to V1 by V2. Then mean effective pressure P is equal to work done divided by stroke volume. Now we are going to solve the problem. First, you have to find the efficiency of auto cycle. What are the values available in the auto cycle efficiency formula? 1 minus 1 divided by R power gamma minus 1. So in this problem, we know the value of gamma. Gamma is equal to 1.4 for normal air. But we don't know the value for R. R is equal to V1 by V2. Then That means now we are going to find the V1 and V2 value. How to find the V1 and V2 value? So V1 and V2 is process 1 to 2. The process 1 to 2 is adiabatic compression. So how to find the V1 value? Take a gas law. PV is equal to MRT. For first point, P1 V1 is equal to MRT1. We know that P1 value and M value, R is gas constant value, temperature value. These values are given in given data. MRT and P1 value. Now we easily find the V1 value. So to find the V, MR T1 divided by P1. All the P1 and T1 values are we have. So V1 value is found. Then point 2 we find the V2 value. In point 2 V1 minus V2 is equal to Vs, swept volume. So already we find the V1 value, substitute the V1 value in swept volumes formula. So our formula is Vs is equal to V1 minus V2. So substitute the V1 value in this formula, easily automatically we get the V2 value. Then to find the Otto cycle efficiency, we want the V1 and V2 value. V1 by V2 is equal to R. So we know the both values. Substitute the V1 by V2 value in R value. The first required data is find it. They ask the compression ratio. Then substitute the R value in efficiency formula. So 1 minus 1 divided by R value is 6.86 power gamma minus 1. Gamma is equal to 1.4 for normal air. So from the three required data are available, we find the two required data. Then we enter to the mean effective pressure. The general formula for mean effective pressure is PM is equal to work done divided by stroke volume. So we know that what are the values we know in mean effective pressure. We know the stroke volume already given in the problem. Then now we want to find the work done value. How to find the work done value? To find work done, we take the efficiency formula. Efficiency is equal to work done divided by heat supplied. So we know that Otto cycle efficiency, already we find it. Then we have to find work done and QS, heat supplied. For Otto cycle, QS value, where the heat is added, process 2 to 3. The process 2 to 3 is constant volume process. What is the formula for constant heat added for the constant volume process? QS is equal to mCV into T3 minus T2. Here we know the M value and CV value. CV is equal to 718. So M is equal to 1. Then to find the QS, we know the T2 and T3 value, but we did not know the T2 and T3 value. How to find the T2 and T3 value is, first you take the PVT relationship for point 2. So point 2 is adiabatic compression process. What is the formula for PVT relationship for adiabatic compression process? You take the pressure and temperature. So T2 by T1 is equal to P2 by P1 power gamma minus 1 divided by gamma. Substitute the values. What are the values we know? We know the T1 value, we know the P1 value and P2 value. So P1 value, P2 value and P3 value. The substitute the P1, P2 and T1 values in this formula. Gamma is equal to 1.4. So easily we get the T2 value. Then T2 value is found. Now we are going to find the T3 value. How the T3 value is found? So T3 is here. This is constant volume process. Take the PVT relationship for constant volume process. So constant volume process for PVT relationship is P2 by T2 is equal to P3 by T3. In this formula, we want only T3 value. So the formula is changed to this terms. T3 is equal to T2 by P2 into P3. So these all these values are we know. So T2, P2 and P3. Substitute the values substitute the pressure and temperature values in this formula and get the T3 value. Why we find the T2 and T3 value? To find the QS. So substitute the T2 and T3 values in QS formula. Substitute the T2 and TS values in QS formula. MCV into T3 1676.45 Kelvin minus 628.67 Kelvin. Substitute the values in this star formula. We get the QS value. So then you substitute the QS value in this efficiency formula. Already we know the efficiency and QS value. Then you find the work done. Substitute the efficiency and QS formula in equation 1. Then we find the work done. Work done is 403.43 kilojoule. So substitute this work done formula in mean effective pressure. So mean effective pressure having work done and stroke volume. Already we know the stroke volume. That now we find the work done. Substitute the both values in mean effective pressure. So PM is equal to work done 403.43 kilojoule divided by stroke volume is given 0.711. So we find the mean effective pressure 5.67 into 10 power 5 Newton per meter square or 5.67 bar. Now you write the result. Result, first one, efficiency of Otto cycle is equal to efficiency of Otto cycle is equal to substitute these values. Then compression ratio R is equal to, then mean effective pressure PM is equal to. So whatever problems they give, first you read the problems 3 to 5 times. First understand the problem and know how to write the given data. If you write the given data correctly, the problem is very easy. Otherwise the problems are very difficult to solve.